Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
This is the Web Platform Podcast, episode number 55, Go on the Web. I'm your host, Danny Blue. With us we have Christian Smith, Erik Isaksen, and AJ O'Neal.
Hello.
Hey, everybody. So, and as you can maybe guess from the title, we are talking all about Go, or GoLang, as some people will probably see it written a lot on the web. And we have a very special guest, Andrew Gerrand.
Hello.
Tell us, who are you? So, one, what is this Go thing? What is this weird two-letter programming language that people keep talking about and you see popping up everywhere, and who are you in relation to that? And we'll just start from there.
I'm Andrew. I actually work on the Go project and have done for about 5.5 years. So I joined the team just after the public open source launch, which was in November 2009. And my role has basically been to represent developers as far as the Go development has gone. So trying to improve tooling and documentation, the contribution process, managing the open source project in general, like all of our contributions, and so on. And so the Go project is a project that began as a project inside Google. It was always intended to be an open source project, but for the first sort of 18 months to 2 years, it was sort of done by a small team inside Google and then released in 2009. So it's a programming language, as you probably know. And the original sort of goal of the programming language was to provide a better way of writing the kinds of software that we write at Google all the time. And outside Google, like we call them servers at Google, but outside the architecture is more commonly referred to as microservices. So Google is basically just this big sea of servers that talk to other servers that do things. And a lot of them are written in C++ and Java, but certainly not C++ and not really Java, were designed to be used by large teams. And Google consists of many teams that sort of form larger teams. And we have sort of one big shared code base. And there are a lot of properties of those languages that we were using that were not really suitable for working at that kind of scale. But it just so Go was an effort to sort of take a lot of their software engineering principles and lessons that we'd learned and turn it into a general purpose computing language for doing the kind of work that we do at Google. Now, it just so happens that a lot of those design decisions that we made to support Google working at scale also make for a really nice programming language, even working in the small. It's something that I've been using personally for pretty much everything since I started working on the project. Yeah, it's a really nice little language for getting all kinds of things done.
So give us like the very, very, very basic details. You know, is it a compiled language? Is it interpreted? Is it statically typed?
Yep. So it's a statically typed language. So you get a nice rigid type system which you can use to clearly define all of your data structures and so on. And it's a compiled language. Like C, it compiles on a variety of platforms to machine code. But unlike some compiled languages, it has a runtime and it's garbage collected and memory managed. So it doesn't let you do any sort of manual memory management. Instead, you just let the garbage collector handle the deallocation of stuff. So anyone coming from a scripting language background would be pretty comfortable with Go. One way I heard it described by Brad Fitzpatrick, who's also on the Go team, he said that it was saying goodbye to the trade-offs. So he'd typically done a lot of web programming. He found that he was using Perl at that time or other dynamic languages for doing like the sort of front-end work stuff that doesn't need to be particularly fast, but you wanted a nice expressive language to do that work in. But then when it came to the low-level stuff, he would have to step down into C, for instance, to really get the speed that he needed. But Go sort of doesn't ask you to make that trade-off anymore. It's really fast, but it has the kind of feel of a scripting language. The compile times are really quick, so you're sort of write, compile, test cycle is as short, or sometimes even shorter, than working in a lot of popular interpreted languages. So it kind of sits in this niche between the sort of popular scripting languages and the sort of older school like systems languages like C and Java.
There's actually I don't think I made this up, but I think there's a story floating around that Go started to be thought up and written while waiting for C++ or Java code to compile.
Yeah, I mean that's actually more or less true. I think Rob Pike, one of the language designers, was working on a particularly large internal Google project, which is one of those programs that kind of, unlike a microservice, became quite monolithic. And despite having a lot of incredible infrastructure to make C++ development tenable at this scale inside Google, we're still looking at compile times of like 20 minutes to half an hour, which is, gives you plenty of time to think about alternative ways of doing things. And it's not really, that story is not meant to bash C++. I mean, it's certainly taken us a really long way, but rather just to illustrate, there were definitely a lot of lacking aspects of the development environment that we had. And Go is kind of an answer to those wants.
So where does the code base live? Because I've seen the Go port on GitHub. Is that the main repository now that code.google is not really supporting projects?
Yeah, so we moved to two places. Google has its own Git hosting, which we use for hosting like the Android and Chrome projects. And we use that because it provides Gerrand, which is a code review system. And so this is a managed service that Google maintains for its own projects. And so we're using that for all of our development. But then we also have all the code mirrored to GitHub, and we use GitHub issues and the GitHub wiki. So while the core repo at github.com/golang is not the canonical repo, it's always kept up to date with the canonical repo, and it's definitely sort of the home of the project now that code.google.com is shutting down. And moving to GitHub was actually a really nice move because I appreciate being a lot closer to our users. I mean, most of our users were developing Go code on GitHub and so on anyway. So now we get all the cross-references between Go issues and Go commits and other projects on GitHub. And I guess I should say, the Go project is actually quite a large open source project now. We've got more than 500 contributors, and most of those people are not from Google. So we have like an active development team that's quite small that work full-time on Google who are employed by Google. Who work on Go who are employed by Google. But there's also many people that are like committers and core contributors to the project that are not from Google. So it's very much a open source project at this stage.
Andrew, how have you guys managed the growth in the project? I mean, I run a very small open source project, and we have a handful of contributors, and project management is all of a sudden a thing. It's something that we have to think about. As you guys have grown so fast over the last few years, what have you had to do differently? How have you had to change what you're doing to make this work for everyone?
Well, I think in general we've actually been pretty bad at managing contributions, mainly because we've just been so time poor. We've got a lot of ambitious stuff that we've wanted to get done, and sometimes that's taken away from the time we've been able to spend actually sort of ramping up contributions from the outside world. But we're sort of making efforts to structure the project better so that we can better involve people from outside the core team. And a lot of that is really to do with communication. When a project gets to a certain size, you have to move from there being a sort of small group of people who all know what's going on to everyone sort of sharing their knowledge about what's going on in a common way so that everyone else any outsider can understand what's going on as well. And I think that's a culture shift that we're sort of working hard on to change. And part of that is we just introduced a proposal process for people who want to make changes to the Go project. And it's basically codifying the development process that we were already using, but it wasn't a process that was obvious to anyone who wasn't already working on Go. So I think the answer is it's complicated. I don't think, like, while many of us had experience working on large open source projects before, we kind of weren't really prepared for the degree to which Go has succeeded and attracted people to the project. So I hope that our ability to manage that growth is getting better. One thing that's really challenging for me in particular is, I spent the first sort of few years thinking about, the early adopters and like the expert kind of developers. And so a lot of our materials, documentation and so on are all geared towards that kind of level of programmer. But now the audience and the interest has grown so much that we really need to start appealing more to the sort of intermediate to beginner developers as well. And that really requires that you prepare all your docs in a much more pedagogical way as opposed to a sort of reference style, whereas most of our documentation at the moment is very referencey. You kind of need to know what you're looking for and how it fits together to really make great use of it. So that's kind of the next challenge for us, really, as the project grows, is just to make things friendlier and more accessible to a wider audience of people.
You said before that, like, if you're used to scripting languages, that you'd feel a little more comfortable. I don't know what the exact wording was. I forget, but a little more comfortable with Go. Like, if I'm a Node developer or a JavaScript, front end person, what would I use Go for in my processes?
Well, I mean, if you use Node, you can pretty much replace anything that you would use Node for with Go. And Node was it came along at this time when people were trying to do more and more on the back end, and more people who'd done a lot of front end work wanted to work on the back end. So it's kind of this revelation that you were able to use JavaScript for writing servers. And I was immediately attracted to Node when it came out. But sort of when I saw Go and when Go came along, I sort of realized that it kind of obviated the need for Node in my life entirely. And one of the major strengths of Go that I see over Node is that it doesn't force you to structure things in terms of non-blocking I/O and callbacks. And I find that the way it works in Go is we have this lightweight threading model that's based around Go routines, which sound a bit like coroutines, but basically they're just really lightweight threads. And if you want to write code that does like a network call or reads from a file or so on, you can just do that, write the code that in the sequential manner, and let your code block. And the scheduler will handle, scheduling new work while that Go routine is blocked, reading from a file, for instance. And so it means that you don't need to think about, which calls are going to be blocking versus not blocking. You just write the code in a straightforward manner, and the scheduler takes care of handling everything for you. So you get the performance of an event-based framework, but with the simplicity of just writing it in a sequential kind of straightforward manner. So that's one of the things that really attracted me to Go initially, because I came from a web development background myself, mostly using Python, doing a lot of Python-based stuff. The other thing that I think was attractive to me was actually having a statically typed language. But it didn't, initially it was like, oh, it's statically typed, this is going to be a lot of bookkeeping for me. But I find that the way the language is designed is it uses type inference a lot, so you don't need to specify the types nearly as often as you do in, say, C, for example. You can write code that looks very light on the page, but actually has that structure that can be checked at compile time. And I find that a lot of the things that I was testing for in writing unit tests in Python was stuff that the compiler can actually catch for me in Go. So I save a lot of time being able to rely on the language to do that for me.
On that note, I'm a Node developer, and I was thinking, in my Node style, and I wrote a little Go program that was supposed to use some JSON that I was expecting to be in this, folder where I have my Go program. But then, of course, it compiles, and then when I ship that compiled program, the JSON isn't there anymore. So what's the story with, because like in Node and in Python you have things like dir name or whatever, like these globals or these constants that represent the file path and file structure. You don't have that in Go. So what's the story for like embedding JSON or binary data or or things like that, where traditionally as a scripter you're thinking that path is important and part of your package.
So there are two ways of going about doing it. One of them is to think more like someone distributing an application. So, if you download a program that isn't open source, for instance, you get a zip file or something, and inside the zip there's an executable and some resources. And, by habit, we sort of keep those things together, right? And so you can write your code to expect the binary to be in the same directory as the resources, and just at runtime you can look at the location of the command that you're executing by checking the environment and locate the resources that way. So that's assuming that you have some distribution process that's separate from your source control and so on. But if you want people to actually fetch your repository and build the Go code, and then it gives you a binary in some other directory, you can actually bundle resources into the binary, and there are various tools for doing that. Basically, they just read the source files in, and then produce a Go source file which has some constants in it that represent the contents of those files.
So I think I've seen some like YAML and JSON tools for that, and I'm relatively new to Go. I've been using it a little bit, but I've seen like other examples where they have a syntax with like I think it's like a triple tick mark, and then it'll be like the name of the file and then like the name of the module that's supposed to load it. So it's just parsing, like it's acting as a pre-parser in that case.
Yeah, I mean that's one approach. It's probably not. I mean, there are lots of different ways to do it, and so it depends what tool you arrive on. I can actually, if you guys have like a write-up of each show, I can give you a link to something that you can put up afterwards. There's also one other way of doing it, which is there's a Go library in the standard library called go/build, and it lets you consult your workspace, which is where every Go programmer keeps their code. And you can look for your source repo inside the workspace and get the directory at runtime, and then look up the resources in that directory. So that's yet another approach that you can take. But I think it would be nice to have a sort of centralized, unified story as to how to bundle resources with binaries, but we just haven't kind of arrived at that design yet.
You had mentioned a little earlier about Go routines and how you don't have to worry about blocking versus non-blocking, because they'll, it's blocking in a Go routine and your main thread is free to execute, so you're getting the same benefit as you get in Node. But I've also read that people doing initial tests with using multiple cores and spreading their Go routines across multiple cores, they actually get a performance decrease. And I don't remember what cases those were, but it sounded like it was if you use a Go routine that does very little work, then there's more work in the context switch than there is in the Go routine. So I was curious to know what your take on that is. What's a good practice or a bad practice?
Yeah, I mean, that used to be the case, but basically, the reason why that happened was that the scheduler was a little bit naive as to like which Go routines were related, and so when you schedule those Go routines across multiple processes, you would often see like two Go routines executing on separate cores that each kind of share some common state, and so there would be like cache thrashing going from one to the other. In Go 1.5, which we're issuing the release candidate tomorrow, we've totally redone the scheduler and the memory allocator and the garbage collector, so it's much more aware of what your program's actually doing. And so originally we had this setting called Go max procs, which is the number of operating system threads that should be executing Go code at any one time. And it was traditionally set to 1 because of this kind of naive scheduler that we had. But now that we have an improved scheduler, we've done some tests, and almost always there's no significant overhead with spreading the load across multiple processes. And also, in a lot of cases, it's just an outright improvement. And particularly for things that are actually parallel, it's a big improvement. And so we've actually changed that default for 1.5 to use the number of available processes as opposed to just 1. So yeah, that was a real concern, but as of 1.5, it's not a concern anymore. So that's really exciting. It lets you write the kind of naive, create as many Go routines as I want to do this, to handle this problem, and not really see any drawback from doing that. Of course, if you are writing something parallel, inherently parallel, like embarrassingly parallel, say you're like computing a fractal image, for instance, if you create like one Go routine for each pixel in the image, it's a nice parallel way of organizing it, but it's not going to be very efficient. I mean, each Go routine that you create is at least, 2 or 4 kilobytes of memory. So when you're carving up something that's like embarrassingly parallel, you still need to consider like what is the overhead of a Go routine versus the job I'm actually performing. So, if you were computing a fractal or something, you'd probably divide it up by line or by some rectangular segment or something instead of firing off a Go routine for each one.
I was going to say, what about a web process where you want to have, up to 10,000 connections at a time?
In a web context, the way the Go HTTP package works is for each incoming request, it fires up a Go routine to handle that request. And you can create more Go routines inside that Go routine to handle the connection, and you can easily handle tens of thousands of connections with a Go binary that way. The overhead of an HTTP connection is like an order of magnitude more than the overhead of a Go routine. So it's not really like to the operating system, I mean. So yeah, it's definitely a model that works for us. It's definitely a model that works for web developers using Go. And it's a really nice sort of clean way to reason about programming in a web context as well. We've seen systems running, handling hundreds of thousands or even millions of HTTP connections simultaneously without any problems. So that whole, the C10K problem, getting your HTTP server to handle more than 10,000 connections used to be a problem that was limited by the number of operating system threads you had available. The event-driven frameworks and like the ePOL-driven stuff made that more tenable. Like Nginx can comfortably handle huge numbers of TCP connections. But that's the result of really careful, intricate programming in the core loops of those programs, right? But in Go, you can just have a for loop that's literally the heart of Go's HTTP server is just a for loop that says, accept an incoming connection on a socket, launch a Go routine to handle that connection. And then it just keeps looping, accepting connections and firing off Go routines to handle those connections. And Go itself, the Go runtime, handles making that efficient. So if you're writing something that's not HTTP, if you're writing some other kind of network server, you can use that same approach and get all the benefits there. We haven't put any magic in Go's HTTP stack.
Just as you were speaking, another thought came up, something that I learned recently. I'm not sure whether it's true or not. It's not specifically related to Go, but I've heard that if you want really high availability with your HTTP server, you actually want to resort back to HTTP connection close rather than connection keep alive. And do you think the way that, first of all, is that true at all? And secondly, with Go, does it hold true?
I mean, I'm not like an HTTP wizard. Like I know that if you get to really high levels of high throughput, high number of connection HTTP serving, there's a lot of kind of things you can tweak to make it better. I know that if you leave a Go HTTP server open to the internet, then you're not going to have any problems. It's fairly well hardened against all kinds of sort of attacks. The one thing I think you might want to adjust is related to keep alives is the connection timeouts. So I think right now, if you open a keep alive connection to a Go HTTP server, it may sit around indefinitely, or the timeout might be sufficiently high that if you have a large number of users, you might end up with a lot of idle connections.
I think the default's 120 seconds pretty much across the board with what I've used.
Yeah,
I don't know about Go. I would think that makes sense.
So I think that sounds about right to me, but I know definitely, in some production environments, you might want to tweak those values, which you can do fairly easily with Go. I have heard of people putting various proxies in front of Go. Some of them are actually written in Go, so sometimes I actually wrote a simple web frontend called WebFront, which is on my GitHub page. And it's just a Go service that forwards HTTP connections to various backends based on a configuration file. And putting things like live failover and health checking and stuff like that into a program like that is fairly straightforward. So I know of a bunch of people that have written their own custom sort of Go HTTP reverse proxies. So I think probably the main reason you want to do that is to be able to have that, being able to update or replace your service without having it offline. So you want to keep the connections open and switch to a new backend. That's kind of why you want a proxy in front of your Go binary. But I mean, otherwise, I know of a lot of people that just run just pure Go HTTP servers open on the net and serve traffic fine, and it works well. So you don't necessarily need like Nginx or Apache or something in front of it.
Well, yeah, I mean, I think that's more a question of scale. Like, until you've reached the 10,000 problem, it's probably not a problem you need to worry about closing your HTTP connections or whatever.
Yeah,
it's just
and I mean, these days you'd probably use something like, Amazon's Elastic Load Balancer or Google's Load Balancer on their cloud platform, something like that. That would be the obvious way to deal with it, I think.
Yeah, the obvious way is to let somebody else handle that problem for you.
Yeah.
You were talking about how you get pretty much most of the benefits of a language like C or C++ with Go, but you get also all the benefits of a scripting language like Node or Python. But you didn't really talk much about the trade-off, which I feel is the runtime. And I think that I'm not cool enough and smart enough to really know what the impact of that is, but I noticed that Go binaries are a minimum of, I think it's 2.4 megabytes. And I know that there's some setup in the runtime, and that's where the garbage collection and a lot of the language features are handled in that runtime. So I wonder if you'd talk about that a little bit, C as opposed to Go as opposed to something that's got a virtual machine.
Sure. Well, just a minor correction. I wasn't saying that Go has all the benefits of C and C++ and all the benefits of scripting languages. There are definitely trade-offs involved. For me, the Go has the right mix of the features that I wanted from those environments. So it's not as expressive as Ruby, for instance. But in some cases, that's a benefit. If you're working with a huge team of people, expressiveness is actually a bit of a negative because it lets people be a bit crazy, right? And Go being memory managed is not necessarily going to be as fast as a well-tuned C program, for instance. If you have total control. Because C is really a glorified assembler in a lot of ways. And, you can write code that's as fast as your machine will let it be in C. So you don't get that in Go. There are restrictions placed upon you to make garbage collection work, to make memory safety work, and so on. But now that I've said that, I've forgotten what your actual question was.
What it means to have a runtime.
Right.
Because I don't think there's as many languages that have runtimes as there are that either have virtual machine or that are direct to assembly.
Sure. So Java or Node or Python or even Ruby, they all have runtimes of a sort in that they run on these virtual machines which handle memory management. Some of them handle the networking stack. They basically just give assistance to the running program or just run the program. With Go, the runtime is actually it's just a package or a library that's linked into every Go binary, and so it's the first thing that's executed. It sets up the memory manager, it sets up the garbage collector, it does some networking stuff, it looks after things like the system time, and then the Go programs themselves hook into the runtime when they do things like allocate memory or do other things that the runtime is responsible for, like managing hash maps that the programmer writes. That code is all in the runtime as well. But so if you think of it as like a fundamental part of the standard library, that's kind of the best way to think about it. As far as the costs of having that runtime, there are a couple of different axes. You mentioned the binary size. Go binaries, the reason why they're so large is because Go is statically linked. If you have a C program that does roughly the same thing, and you compile it as a statically linked program, it is about the same size as a Go program. It's just that most C programs are dynamically linked and just load shared object files at startup. So like a C hello world that's dynamically linked is a few kilobytes, whereas a Go program, hello world program that's statically linked ends up being a few megabytes. But if you statically link the equivalent C program, you do end up with a file about the same size. We actually have in 1.5 introduced shared library support in Go, and so you can actually see the direct comparison. If you compile a hello world program with shared libraries turned on, the actual executable is just a few K, just like the C one. But with that said, the basic support that you get in the runtime and the standard library gives you a lot more than traditionally what you get in C. For one thing, it handles Unicode, so all of the sort of tables involved with managing Unicode strings are all in the files, and also just drawing a blank. The other thing, Go code can reflect on Go code. So at runtime, you can say, what is the type of this value? You can enumerate like the methods on a type and dispatch on those methods at runtime using Go's reflection capabilities. And things like, Go's JSON encoder, which looks at a data structure and then converts that from a Go data structure into a JSON object, it uses reflection to do that. And all of the annotations in the source code that make that reflection possible also increase the binary size. And so that's why you'll see a Go binary being bigger than your equivalent C program. But it's basically just because there's more stuff in there. If you wanted to, it allows you to do more. But there is an open bug to reduce the size of Go binaries, and it's something that we can still improve yet anyway.
After all that explanation, I mean, yeah, but yes, we are trying to make them smaller.
Well, I was speaking mainly as to like what the runtime is for. But yeah, I think there's probably some wastage in there that can be improved. We've just completed a migration of the entire compiler toolchain from C into Go. We recently converted the toolchain from C to Go, which we did mechanically using a converter program. And since that conversion, we've been like refactoring the toolchain, like the compiler and linker and so on. And so the kind of work that we need to do to, say, reduce the size of Go binaries will be much easier now that we're working in a more comfortable language.
Awesome.
So one of the things I really love about the JavaScript community, since that's one of the communities that I am very near and dear to my heart, is that they have npm and Bower, and there's all these package managers that I can go to and find lots of stuff. So, for instance, I was getting really upset the other day about the data object in JavaScript, and I was like, I wish we had drift time, and lo and behold, Substack has a npm module for that. So one of the things I found struggling was I can't really find a definitive package manager story for Go. Can you kind of talk about that?
Yeah, sure. So this has been something that has been mildly controversial, I guess, for a while, which is Go's approach to this is decentralized. And so when you want to fetch a dependency, you actually fetch it by its URL. And the URL is actually in the source code itself. Like when you import a package, you import it using the URL as the import string. And the nice thing about that is we can automatically locate and install dependencies just from the source code alone. But one of the downsides of that is that there's no facility for versioning in that scheme. It's a very simple mechanism, but it doesn't know like what version. It always just fetches whatever is at master. And so there are a number of like tools to assist with this, like managing of dependencies, and most of them revolve around like writing some metadata file and pinning the version of those dependencies at a particular revision. But as far as having like a repository of packages that you can consult, there's this fantastic website called godoc.org, which is a site that provides the documentation for open source Go packages. Everyone uses this to look at their own docs, and so we actually compile this index of all of the packages that people look up, and so there's like everything there. And so if I wanted to look at, say, there's a Gorilla Web Toolkit and has this Mux package, this is all documentation derived from the source code. And so you can see all the types and functions exported by the package, and you can see how they work and what their documentation is and so on. But the nice ramification of this is we actually have a search across all those packages. So if you said you wanted strf time, we don't have that in the standard library in Go, but there are people who've implemented it, and we kind of have a nice sorting algorithm to give you a useful result first. So there's this Go strf time package, which you can import using that string, and it just has the format function, which takes a strf time string, and they even have a little example of how that might work using a time value and then calling format to format that string. So godoc.org is just this tremendous resource for people looking for open source Go code. And then once you have the dependency that you want, you can use one of the dependency management tools to either store your own copy of it, we've called this vendoring, or just write a metadata file that records the revision that you're using so you can reproduce that build at any time.
And is there like how many packages are covered in there, and what's the process for putting them up there so that people can find them? Because that's like
Well,
a struggle, like with some of the other. That is one of the bad things about the JavaScript, package managers is there's three of them you can that are pretty popular, right? There's the least of those is probably JSPM, and then there's Bower, and then there's NPM, and the search for Bower doesn't find everything all the time from what I've seen in my use, and people are kind of like, oh, I don't know if I should put it on there.
Well, as soon as you look up a open source package with go.doc.org, it's there in the index. So that's how it gets there. If you're the package author, you don't necessarily even put it there yourself. Someone else might look it up and it ends up in there. And so I guess kind of like Google search, we're trying to rely more on signals from the code itself, just like Google relies on information divined from the web pages that it crawls. Because, we've looked at things like CPAN and NPM and so on, and people pounce on common names. If you have some short name that, like JSON, for instance, I'm sure there's some NPM module called JSON or something like that hasn't been touched in several years. That's probably not the best one, but it has the best name. And so we wanted to try and avoid that entirely, and we're hoping that there's go.doc.org, there's also gosearch.org, there's a few other websites that make searching Go code better. There's definitely a lot of ways we can improve it, but that's kind of that's the approach we're taking, and it seems to be working out pretty well. It's definitely not without its problems, but I'm pretty happy with where we're at today.
The only experience that I've had so far with Go is that I installed the runtime, I built a sample app, and I got a web framework that I was using, and then Christian, who's on the podcast here too, introduced me to this static generator called Hugo, and I used that to build a site. And one of the things that I was surprised at, I was like, wow, this is really fast for the build. The build was super fast, and I like that, obviously. So, what are the frameworks that people can use that are for Go for web development? Like, what are the big like Ruby has Rails, right? That's a big one for them. Like, what is the Rails of Go?
There are different schools of thought about, even in the Ruby community, for instance, about these kind of monolithic web frameworks. And, they do exist for Go, but Go's entire sort of philosophy is generally centered around creating small pieces that interoperate through declaring small interfaces between them. And so the standard library has an HTTP package. It also has an HTML templating package, which is quite sophisticated. It has JSON encoding and decoding. It has a database sort of driver, like the abstract driver, which you can plug like community drivers for MySQL or whatever into. And so for doing your sort of basic web dev stuff, you can just do it all with the standard library. And I have done that. A lot of people have done that. But the nice thing about Go's sort of system of declaring interfaces is you can then start, like I mentioned, the Gorilla Web Toolkit. That's a set of packages that provide things like URL routing in a more intelligent way than the built-in one, or a mechanism to take like a form post and stuff the values from that form into a Go data structure, things like that. You can import these packages and kind of take the pieces that you need to make your life easier without having to buy into like a whole framework. With that said, there are a couple of large frameworks. The two that come to mind are Revel and BeeGo, which I think is particularly popular in China. And they both provide a more sort of comprehensive Rails-like development environment.
Yeah, Revel was the one I actually used. That was pretty interesting.
Yeah, I mean, I've heard mixed reports. I think if it works the way that people, if you come to it expecting it to work a certain way and it matches that expectation, then it works well for you. But I find that even I was using Django in Python quite a lot before I started working on Go, and I found like the more I used these big frameworks, and I think Django is a particularly well done one, but the more I used them, the less I wanted from them. And I think that's, you start to see that even in like the Ruby community with Martini being quite popular, just going with like the minimum viable pieces works out well if what you're doing doesn't exactly fit within what, say, Rails is designed to give you.
Yeah, I mean, Sinatra was the small one that I used there, and
Oh, yeah,
I like
Sinatra was
that.
always
I like that a lot. It was very small and easy to do. But one of the things I loved about Ruby and JavaScript both is it's very approachable for somebody new to web development totally. So there's lots of, for new people, there's lots of, okay, here are some tools you can get to put all this together, and you don't have to worry about, all this complexity. But it sounds like right now the Go story for that is, well, we have a lot of, veterans and intermediate people who can understand this and work with it really well. But maybe I'm wrong. So tell me, what's the story for new people?
I think it depends, like, what level of new. If you're talking about, like, I've never programmed before and I want to get into this web development thing.
Well, like junior level, like they're just getting there. They know enough to like blow stuff up.
Yeah, I mean, I actually think Go fits pretty well within that target market. I mean, if I could drop everything that I have to do right now and just do one thing, it would be write an amazing, like, short book about how to get up and running writing web apps in Go. And I think there's nothing about Go or the libraries, the language, or anything that is unfriendly to junior level programmers. And in fact, you can sit down and use Go for a few weeks and pretty much use every part of the language and know how they work. Whereas I used JavaScript for more than a decade. I couldn't tell you that I know all the ins and outs of JavaScript. I know there are definitely subtleties I'm not across. I could say the same thing about Python. And the really nice thing about Go is from a kind of understanding your code perspective, you can click through using Godoc, the documentation viewing tool. You can click through your code and basically trace all the way down to the system call in pure Go code what your program is doing. In that sense, if you want to do the same thing in Node, you end up in their C++ runtime. Or if you want to do the same thing in Python, you end up in their C code base. Whereas in Go, you can just follow everything in Go right down to the system level, which is, it actually, using Go has educated me a lot about how my programs actually interact with the operating system. So I think all of that stuff is really helpful to junior programmers. And I kind of wish that Go had been around, say, when I was in my late teens and really getting into software development professionally, because it would have, I think I spent a lot of time internalizing the complexities of the systems that I'd been using rather than fully understanding how my programs actually worked. So I think there's definitely a bit of a documentation gap as far as like real newbies getting into Go. But I think the system itself is extremely friendly to people who want to learn new things. And there was a great talk at GopherCon by a woman named Audrey, who was totally new to programming a year ago and taught herself Go and web programming and a bunch of other stuff besides in a year and shared the stuff that she'd learned and written. It's a great talk. I mean, she's a truly remarkable woman. I wouldn't say anyone can learn to program from scratch and inside a year be as proficient as she is. She's definitely an extraordinary person. But it was encouraging to see that, it can be done, and it's definitely something that's in Go's future, I think.
I have a kind of a weird logistics question that I just thought of. What's the best IDE to use to write Go code in? Like, I know, like Sublime Text has plugins for it, but what is it?
It's Vim, obviously. There's just one rule more.
Yeah, my pithy response might be Vim, but I'd only say that if you are already using Vim. I wouldn't tell you to switch to Vim and learn Go at the same time. It's harder to learn Vim than it is to learn Go, by the way. But I think there are editor plugins, really good ones for Vim and for Emacs, of course. And there's also a project called Go Sublime, which is a plugin for Sublime Text. So I think Go Sublime is a great. It's like Sublime Text seems to be the really friendly like GUI text editor that people are gravitating towards these days. So I would probably recommend that. I know there's also a IDE called Light IDE, which is written specifically for Go, and that's probably something worth checking out. And I think there's also a plugin for IntelliJ, and in fact, they may be working on a plugin in-house, like the IntelliJ team. I can't remember exactly, but I know we're trying to put some resources behind the Go Sublime plugin to make it a really first-class development experience. I think it's one of those things where we didn't sit down and try to build a Go IDE because it's not really a business that we have time to be in. I think once you start building an IDE, it's a whole another beast of its own. We'd probably need like 4 times as many people as we have now to actually build an IDE.
Well, how big is the Go team?
So the actual Go team that work on open source stuff is somewhere on the order of 10 people, and you can see that in all of our commit logs and stuff. There are more people inside Google working on Go, but that's Go support for Google programs. So interacting with all of Google's internal infrastructure, there's a lot of work to be done to make that possible. Yeah, it's actually fairly small as far as the number of people who actually work on open source Go. But it's one of those situations where everyone on the team kind of has their own areas of expertise and responsibility, and so we've been quite a productive group despite the small size.
Very cool.
But I mean, we really rely on the contributors in the community to get so much stuff done. Like, the really notable thing is the Windows port was driven largely by the community, and they've just been essential in making that possible. And Windows is one of our largest platforms, so that's been a huge win for us.
And is there something you recommend for people to get started with, to help out, or to create something that, let's say if I have a project already that doesn't have anything for Go, like, could I splash in some Go?
Yeah, I mean, if you have an architecture that lets you where you have multiple servers that can talk to each other, then Go will just fit right in. It should be fairly straightforward to fit that into an existing project. I would say, the first program I wrote in Go was taking a bash script that I'd written and turning it into a Go program. And I thought, oh, this is going to be, more trouble than it's worth. And, bash is a domain-specific language specifically for writing these kind of programs. So, my Go program is going to be more verbose and blah, blah, blah. But it turned out that once I started doing that, all those little throwaway scripts that I'd written turned into a suite of nice little programs that I could reuse and extend. And just writing them in Go made them a lot sort of cleaner and more maintainable. So if you have like parts of your project that, maybe it's some hacky script, I would consider, that's a good candidate for replacing with Go and just seeing how it works out. You don't need to learn a lot to get started replacing a shell script. So that's a really nice place to start, is with automation tasks like that.
So my first program in Go other than Hello World was implementing a way to check to see whether or not a port was in use, because you can do it with netcat and you can do it with nmap and you can do it with netstat, but then you have to do hacky things to grep the output or to close the
Yeah.
So I found that was a really easy way just to pick something small, a couple lines of script.
Yeah. And in that particular instance, you're really depending on the strength of Go standard libraries, which make it really easy to look at, system level stuff like that. So I love those kind of little use cases.
Yeah. In general, those are pretty, you were just saying, like replacing bash scripts, but a lot of times those are just good practice, because a lot of times you're interacting, you're moving files around, you're deleting things, you're modifying files, a bunch of that stuff. So a lot of times whatever programming language you are trying to learn, I know one of the first Node programs that I ran that wasn't on a server was doing something very, very similar. So so I'd be good, a pretty good place to start for anything that people are trying to learn. And actually, I may, as I'm digging into it more, I may try to rewrite some of my previous Node scripts that I've done for, like simple things, like up versioning something in a Node package or something like that, which I know there are already things out there that do that, but I want to do it myself. But so just redoing things that do small things like that is a good way to get going.
Yeah, I mean, in particular, like anytime you're moving files or deleting files, it's a really good idea to maybe think about using Go for that, because we've all seen, like, wasn't there was a bug in a high-profile project? I think it was what's the Mac package manager homebrew? There was a
Homebrew.
like one character missing in a shell script in the homebrew thing, which caused you to do like rmrf/ if you had the wrong environment variable set. And I think shell as a scripting language really makes it too easy to make those kind of mistakes. So that's one good reason to use something else.
I think everyone has made that mistake at one point.
Yeah. Think very
There's
hard.
always that one panic.
Right.
Yeah, that one panic moment of, oh God, did I just blow everything away?
Yeah.
But,
Yeah.
but okay, well, we're starting to bump up against our time here. Does anybody have any last minute questions that they wanna sneak in there before we sign off?
I definitely do.
Go for it, AJ.
All right, so I have two things here. One, so when we have Go routines, we bump into, well, maybe we don't need to, but I feel like shared memory is something that I'm familiar with, and I'm not necessarily sure how to do that with a Go routine. I know channels are supposed to help. So I want to give a scenario and then get some advice. So let's say that I have a server, and there's a global config object for the server that has some, well, it's got some configuration stuff. And I want to be able to say, with an API call, okay, change some of your internal config. And then as new requests come in, I want those requests to be handled with the change in config. Like, how does one manage that kind of thing?
Right. So a really straightforward way of doing that is you can have like a global config struct, like a data structure with some configuration in it. But you make the global variable a pointer variable. And so when the program starts up, you allocate like a config struct and populate it with that configuration. And then when each process goes to handle a request, it can use one of the atomic primitives, synchronization primitives in the standard library to load that pointer to the config in a thread-safe way. So it gets the current value of that pointer. And so it sees the current configuration. And when you update the config, you allocate a new config struct and populate it with the new config, and then you use the same atomic primitives to update that global pointer to point to the new config.
So what are those primitives, like the mutex lock kind of stuff, or?
A simple way to do it would be to just use a mutex and access that config with the mutex held. And actually, the mutex that you would use is probably the read-write mutex, which is in the sync package. And it lets you have multiple readers all accessing the data simultaneously. So that's your common case, requests coming in, config being accessed by all of those Go routines that are servicing the requests. And then in the minority case, where you're actually updating the config, you take the write lock, which waits for all of the readers to be finished with the read locks, and then takes the write lock, you update the config, and then release the lock. That's probably the simplest way to do it. It's probably also performant enough to be fine in almost all situations. If you did find that taking the mutex and releasing it was too slow, or there was too much contention, or you're updating your config too often, you could then look at the sync/atomic package, which has other primitives like compare and swap pointer or load pointer, which let you access shared values in a way that's thread safe, done atomically. But that's probably more than you would really need. You'd probably just be fine with the mutex.
Okay, and I heard one person say that a good way to handle it would be to have a Go routine manage the object and then use a channel instead of a mutex. Do you think that kind of approach is a good idea, or is that a code smell?
I think in in the very simple situation you've described, that sounds like overkill. And I think people see, like, channels are a fantastic way of structuring a lot of problems. They're particularly good for doing things like distributing work to multiple Go routines, or fan in, fan out kind of patterns, and a bunch of other patterns. They're really great tools, but they're not always the best tool. And in the case that you're describing, where you're just simply sharing a data structure between many readers and few writers, a read-write mutex is the simpler way to organize that. If you wanted to do something like notify long-running processes that the config has changed, then using channels might actually be a more practical way to do it, because it's possible to see if there is new information available on a channel and use channels to kind of broadcast information to a bunch of running processes. So depending on the specifics of the problem, I could see using channels there, but it sounds like a job for mutexes in the most part.
Okay. Yeah, because I think mutexes are a lot of web developers are probably not very familiar with that problem. And when people talk about Go, they talk about how great the concurrency story is. And I think sometimes the fact that you still need mutexes in some cases might be overlooked in a lot of people's story that they hear.
Yeah, I mean, the first talk I gave about concurrency in Go, one of the first things I did was create a shared data structure with a mutex wrapped around it. So they're definitely well used in Go code. But knowing when to use which primitive is definitely something that you learn with experience. And you'll definitely at first write the kind of crazy channel spaghetti code just because it's fun, and then you see simpler ways of doing it. So I think, like anything, when used properly, any of Go's concurrency primitives can make things simpler, but they can also make things more complex. It's just a matter of choosing what to use at the right time.
All right. Well, if you've got any like blog or article or anything to link to help someone who wants to discern, I'd love to see those in the show notes.
Sure.
And then the last question I had was, so as far as I'm aware, Node, Angular, and Go all were being developed pretty much concurrently. And Node caught on like wildfire. And then Angular finally appeared about 2 years ago in the mainstream, and now Go is just starting to catch on. And to me, the first Go talk I saw, I was like, wow, this is superior. So do you have any idea why it's taken so long to catch on? Has it been the growth issues you were talking about, or features that were lacking, or maybe just the coincidence that Node solved a similar problem in a more familiar way?
I think we're really talking about different things, because Node is not a language, it's a environment for an existing language. So if you take a language like JavaScript that's been around for like 20 years, and then allow you to use it in a new context, immediately you have this whole group of programmers who already know how to use JavaScript, and so they feel comfortable, and it's something that people can immediately start using. So I think that explains the popularity of Node. But I think if you look at the trajectory of new languages, Go has actually had a really kind of meteoric rise. Inside of 5 years, we have a really strong community, large number of people involved, major conferences in several continents around the world every year. So I think that if you look at it at a language level, Go is actually succeeding incredibly well. So I don't know. I hope I haven't come across as like dissing Node or JavaScript or anything.
No. When I first saw Go, I just was blown away, and I was like, this is going to be big. But then I didn't start using it because I was still kind of like, well, is it? Maybe. But I felt like, wow, this is amazing, and I'm so glad to see that now it's really taking off. It just seems like, I guess when you put it in that perspective, it has been really quick. It's just from my frame.
Well, I think there's also the Google factor, right? When Google does anything, it attracts a huge amount of press, and so people expect it to be a really big deal straight away. But if people who weren't Google released Go, it wouldn't have gotten nearly as much attention, and maybe the growth rate would have been the same based on like the kind of people that were attracted to it, as opposed to the people who just know about it. But I think it would seem more impressive if it didn't have this specter of Google behind it. I think when we, see anything produced by Google, you just expect it to be huge right out of the gate. And I think for any programming language, that's not really feasible, right? You need to build up your user base over time and build the expertise in the community and really make sure the community feels like they own the language as well as the original developers. So I'm really happy that we seem to be hitting all these kinds of goals and making the progress that we are.
Amen.
That's awesome. Yeah, no, that's great. I have one kind of tag-on question to that as well in terms of adoption. Have you seen more adoption starting to pick up in the enterprise space as well, like not just at Google, but in other large enterprise solutions?
Yeah, absolutely. That's been really gratifying because the enterprises tend to be the more conservative users, and we've even seen Go being used by really large companies in the United States and in Europe, and we've also seen Go being used by governments, which is really reassuring because they tend to be incredibly conservative. So we're definitely edging into those markets. I think it will take many years before we see Go as like a really major player in the enterprise market, just because all that institutional inertia makes it really hard for people to switch to new technologies. But I think Go as a language is conservative enough that it's appealing to people who run large businesses. You can hire someone and have them writing Go code productively. If they have a general programming background, they can learn Go inside of a couple of weeks. And so, we've had a lot of people telling great stories about ramping up new employees on their Go code bases with a lot of ease. So hopefully that will make Go a lot more attractive for larger enterprises.
That sounds Reprise is a tough nut to crack. I'm glad to see that it is spreading out, not just amongst open source developers or smaller companies. But that's great. If there are no other questions for Andrew, I think it's time to start wrapping up. Andrew, thank you very, very much for coming on the show and hanging out with us. If people want to get in touch with you, if they want to know more about Go, if they want to help contribute, since Go is an open source project, how can we do that?
Well, you can contact me directly. I'm adg@golang.org, or I'm on Twitter as NF, ENNEFF, or you might want to just mail the Go mailing list, which is Golang Nuts at Google Groups. And there's a weird story behind that, but it's stuck.
Sure there is.
There's also the Gopher Slack channel. If you use Slack, you might want to look that up. The gopher is our mascot, and Go programmers call themselves gophers, for better or worse. So
that is adorable.
Yeah, I have. Oh, look, here we go. You can see my little gopher friend. Yeah.
That actually is adorable. I have somebody that's there's one of my buddies at work judges open source projects by how adorable their mascot is. So I think Go's probably can be pretty high up there for him.
I actually haven't seen a cuter one. I may be biased. I'm pretty close to the gopher myself, but it's pretty good. Pretty happy with that. Renee French is the artist who did the gopher and does all the gopher things. So the Gopher Slack channel is a great place to find, a nice warm community of people happy to help. So any of those things, get involved.
I noticed too that RubyLearning.org, Satish Talim, and some of the educators over there, they have really good. I took a Ruby course there, and now they have Go classes. They do some good courses to introduce, at least for Ruby. I remember it was a very good course, and so the Go ones, I'm assuming, are of the same caliber.
Yeah, well, Satish organizes or co-organizes the GopherCon India.
Yeah.
He's gotten pretty into Go, as far as I can tell.
Well, thank you for coming on. It's been awesome.
Oh yeah, if you do want to learn Go, the first place you should go is tour.golang.org, because there's a tour of Go, which basically just teaches you all the basic language concepts in a sort of interactive way. So check that out. It's a great resource.
Andrew, thank you again. Thank you to all of our panelists. Panelists is the way you say that word. So for us at the web platform, This has been episode 55, Go on the Web, and we will talk to everybody next week. Bye.
Thank you.
Thanks for having me.
You want to learn more about what's coming on next on the Web Platform Podcast? Follow us on Twitter at the Web Platform, or on Google Plus and YouTube at +the Web Platform. We also need your help in creating transcripts of the episodes and helping to create open source projects under our GitHub organization. Contact Erik Isaksen at eIsaksen,
or Danny Blue at D_Blue. That's DEE_BLOO.
Thank you for listening, everybody, and we'll catch you all next week.